Imagine a world powered by hydrogen, the universe's most common element. Cars, trucks, and planes glide silently, emitting only water vapor. Hydrogen could revolutionize energy, offering clean power for transportation, industry, and beyond. The question is no longer if hydrogen will play a role, but how quickly we can build this future. Why is hydrogen capturing the world's attention now? The answer: a global climate crisis, political will, and rapid advances in clean technology. Extreme weather and rising seas demand urgent action. Renewable energy is cheaper than ever. Nations see hydrogen as key to energy security and a clean future. Hydrogen may finally be ready to power our world. Hydrogen is the universe's simplest and most abundant element. Just one proton and one electron. It fuels the stars, forms water, and is found in every living thing. On Earth, hydrogen is rarely found alone. It's usually bound in compounds like water. Unlocking hydrogen's energy means separating it from these bonds, an opportunity and a challenge for a clean energy future. To unlock hydrogen as a clean fuel, we must break its chemical bonds, most often using steam-methane reforming or electrolysis. Electrolysis, powered by renewable energy, creates green hydrogen with only oxygen as a byproduct. No carbon emissions. As costs fall, green hydrogen is set to become a cornerstone of our sustainable energy future. Steam-Methane Reforming, or SMR, is the dominant method for hydrogen production today, responsible for about 95% of global supply. It uses natural gas and steam at high temperatures to create hydrogen, but also releases significant carbon dioxide. This gray hydrogen is cost-effective and well-established, yet its carbon footprint is a major challenge for a sustainable, net-zero future. Electrolysis offers a clean, sustainable way to produce hydrogen, using electricity to split water into hydrogen and oxygen, with only pure oxygen as a byproduct. When powered by renewables like solar or wind, this process creates green hydrogen, the gold standard for clean energy. Costs are falling fast and investment is surging, making green hydrogen a promising solution for a sustainable future. Between gray and green hydrogen lies a spectrum of production methods, each with unique benefits and challenges. Blue hydrogen uses carbon capture to reduce emissions, while turquoise hydrogen splits methane into hydrogen and solid carbon, avoiding CO2. As new colors like pink and white emerge, these diverse pathways offer strategic options for building a cleaner, more sustainable hydrogen future. Hydrogen can be used in two main ways: burned for heat or converted to electricity in a fuel cell. Combustion is simple but less efficient and can create pollutants. Fuel cells, on the other hand, generate clean electricity with only water as a byproduct. This versatility makes hydrogen a powerful energy carrier for vehicles, industry, and backup power. The fuel cell is the technological heart of the modern hydrogen economy, a device that embodies the clean energy promise. To understand its magic, let's look inside. A typical proton exchange membrane fuel cell, the kind often used in vehicles, consists of two electrodes, an anode and a cathode, separated by a special polymer membrane. The process begins when pressurized hydrogen gas is fed to the anode side. There, a catalyst, often made of platinum, strips the hydrogen atoms of their electrons, leaving behind positively charged hydrogen ions, which are simply protons. This simple yet critical step is what initiates the flow of energy through the entire system. These newly freed electrons, being negatively charged, cannot pass through the central membrane. Instead, they are forced to travel through an external circuit, creating a flow of direct current electricity. This is the electricity that can then be used to power an electric motor, in a car, light up a building, or run any other electrical device. Meanwhile, the positively charged protons make their way directly through the membrane to the cathode side of the fuel cell. This separation of electrons and protons is the ingenious mechanism that allows the fuel cell to generate a steady and controllable electrical current for as long as fuel is supplied to it. On the cathode side, the final beautiful step of the reaction takes place. Here, oxygen, which is typically just drawn from the ambient air, is fed into the fuel cell. As the protons arrive through the membrane and the electrons complete their journey through the external circuit, they all meet at the cathode. There, they combine with the oxygen atoms in a reaction that forms pure water. This water is the only exhaust product of the entire process. It is so clean, in fact, that astronauts on the space shuttle, which used hydrogen fuel cells for power, would drink the water produced by their onboard energy system. This entire electrochemical process is remarkably efficient. While a traditional gasoline engine might only convert about 20 to 30% of the fuel's energy into useful power to move the car, a hydrogen fuel cell can achieve efficiencies of 60% or even higher. This means more of the energy stored in the hydrogen is put to work, reducing waste and increasing the overall range and performance of the vehicle. The process is quiet, reliable, and scalable. Fuel cells can be stacked together to create more power as needed. It is this elegant, efficient, and emission-free conversion of hydrogen into electricity that makes the fuel cell a truly transformative technology for a sustainable future. Long before hydrogen was a climate buzzword, it powered the Apollo missions, providing electricity and water for astronauts, proving its reliability in space. On Earth, hydrogen became essential in industry, fueling fertilizer and petrochemical production, and building a hidden but vital hydrogen economy. Today, we're reimagining hydrogen as a clean energy carrier, building on decades of experience to power a decarbonized future. As the world faces climate change, hydrogen is re-emerging as a key solution for sectors where batteries fall short, like heavy transport and industry. Hydrogen powers trucks, ships, and steel plants, offering clean energy where electrification is tough. Green hydrogen can even replace coal in steel making, emitting only water. From trains to data centers, hydrogen is powering the clean energy transition. The Hindenburg disaster left a lasting mark, fueling fears about hydrogen's safety. But today's hydrogen technology is worlds apart from the past. Modern tanks are engineered for safety, and strict protocols are in place. By understanding the facts and advancements, we can move beyond outdated fears and embrace hydrogen as a safe, vital part of our clean energy future. The hydrogen transition demands a massive new infrastructure, production, storage, transport, and delivery, built almost from scratch. Unlike fossil fuels, hydrogen's low density and unique properties require specialized tanks, pipelines, and refueling stations. Overcoming these challenges will take years, major investment, and strong government support to create the backbone of a true hydrogen economy. In the race to decarbonize transportation, battery electric vehicles and hydrogen fuel cell vehicles stand out. Both use electric motors for a quiet, emission-free ride, but differ in energy storage. Batteries are recharged from the grid, while hydrogen cars generate electricity on the go. Battery EVs are cheaper and easier to charge, while hydrogen offers fast refueling and longer range, but faces higher costs and limited infrastructure. Batteries and hydrogen aren't rivals, they're complementary. Batteries excel in daily vehicles like cars and scooters, easily charged at home. But for heavy-duty needs, trucks, buses, ships, and trains, hydrogen's fast refueling and high energy density shine. The future of clean transport is a diverse ecosystem where each technology plays to its strengths, accelerating decarbonization by using the right tool for every job. The real question in the hydrogen debate is hydrogen truly green? It all comes down to how it's made. Most hydrogen today is gray, produced from natural gas, a process that emits huge amounts of CO2. So while hydrogen cars emit only water, the pollution is just shifted elsewhere. Only green hydrogen, made by splitting water with renewable electricity, is truly clean from start to finish. The future of hydrogen depends on rapidly scaling up green hydrogen and phasing out fossil fuel-based production. For hydrogen to be a real climate solution, we must invest in renewables and new technology to make green hydrogen the standard. Even green hydrogen faces a big challenge: efficiency. Making, storing, and using hydrogen wastes a lot of energy, so much that hydrogen cars use about half as much renewable electricity for movement as battery electric vehicles. Batteries are far more efficient for most cars and local transport. But for heavy industry, shipping, and long-haul transport, where batteries fall short, green hydrogen's unique strengths make it worth the trade-off. Hydrogen's value isn't in efficiency, but in solving problems batteries can't. Well, why is hydrogen finally taking off now? Because climate urgency and new technology have collided. Governments are setting net zero targets and demanding real action, while renewables like wind and solar are now cheaper than ever. Electrolyzer technology is rapidly improving, making green hydrogen more affordable and scalable. As costs drop, more industries invest, creating a feedback loop of innovation and falling prices. For the first time, hydrogen is moving from distant dream to practical solution. Today, hydrogen is backed by a flood of public and private investment worldwide. Governments are launching billion-dollar strategies, while companies race to build the infrastructure and technology for a hydrogen economy. The EU, US, China, Japan, and others are all in, seeing hydrogen as both a climate necessity and a huge economic opportunity. This synergy between policy and business is driving a global push unlike anything before. The world isn't just talking about hydrogen anymore, it's building it. Hydrogen isn't a cure-all for climate change, but it's a vital tool for the hardest to decarbonize sectors. It won't replace batteries or solar panels, but it will power heavy industry, long-haul transport, and store renewable energy at scale. Transitioning to green hydrogen is a massive challenge, requiring new infrastructure and sustained investment. But for steel, shipping, aviation, and more, hydrogen is one of the only real paths to zero emissions. Used strategically, hydrogen can help build a cleaner, more resilient energy future. The story of hydrogen is unfolding now. After decades of promise, climate urgency and innovation have set the stage for its rise. Hydrogen, the universe's simplest element, is ready for its moment. From fueling vehicles to powering industry, the hydrogen age is here. Practical, powerful, and essential. The time for hydrogen is no longer in the future, it is now.